All right, today we are going to explore piecewise functions. This is when you have more than one equation to describe the entirety of your function. So if you think back to when we had talked about some other real-world examples, and we were saying in reality it's possible that in some years there was exponential growth and in some years it was more linear. This is where you would actually express that using your different functions. So we're going to evaluate them algebraically and graphically, and then we are going to graph some piecewise functions, and we are going to write some as well. So for evaluating, you're going to look at, if I'm wanting to know what f of -4 is, well, I need to look at my two intervals. I'm going to use the first equation when x is less than 0, and I'm going to use the second equation when x is greater than or equal to 0. Now, -4 falls into the category of being less than 0, so I'm going to use x squared plus 1. And when I plug that in, I get 16 plus 1, which is 17. If I want f of 0, this is where I have to be kind of careful because both of these have a boundary at 0, but the bottom is the one that includes 0 because my inequality is underlined. So I'm going to use my second equation here. And then for the final one, I want to add these two together, but first for f of 10, that tells me to use the second equation because it's greater than 0, so that's going to give me 8. And for the second one, I have to use the top equation because that's less than 0, and that gives me 5. 8 plus 5 is a total of 13. Graphically is a little bit easier. G of 4, I'm going to look when my x value is 4, and these grid lines printed kind of lightly, but that is at a y value of -5. G of 1, I have two possible answer choices here, and this is where, just like we had the underlined and ununderlined inequalities, here you would look at your open and closed circles. We want the value with the closed circle. That will be a 1. And then G of -5, over here again, we're going to kind of eyeball and call that -5 as well. And so that is a crash course on evaluating. Now for graphing, I recommend using a table, plot a few points, and then you can get a better idea of what you're working with. So I'm going to look at my first interval here. I'm going from -6 to 1. So in my table, I'm going to put all those values from -6 to +1. And I'm going to look at what my outputs are. So x plus 5 squared, well, I'm going to get 1, 0, 1, 4, 9, 16, and 25. 36. Now, a lot of those aren't going to fit on our little grid here, but I'm going to plot as many as I can. Another thing to consider here when I'm getting ready to graph it is, are these going to be opened or closed circles? And looking at my inequality, they are both underlined, so I need to make sure that both of these are closed. So -6, 1, 5, 0, -4, 1, 3, 4, -2, 9, and so on. And it's going to go up really high. Whoop, that was an ugly parabola. Off my graph, and I'm just going to kind of pretend that I can see where that ends. And so here is my not so beautifully drawn parabola for the first part of our graph. I'm going to switch colors for the second part just so we can see clearly. I want values of x that are greater than 2. So I'm going to start at 2 since that's my boundary and get some numbers on there that are bigger than that. And for all of these, x is just going to be -6. That one's easy peasy. So what this is going to look like is, firstly, an open circle here at the 2 because it's not underlined. So at 2, -6, I've got an open circle. And this interval does not have a second boundary, so this is going to go on forever to positive infinity. So there are my two parts of this piecewise function. The next one also has two parts, so again, I'm going to look at one and then the other. For this one, I need some numbers that are less than -2. And let's just go with, if I start here at -2, -3, -4, -5, again, I'm going to get those by squaring x and then subtracting 3. So that'll be 22, 13, 6, and 1. Only 2 of those are going to fit on my graph, but I need to pay close attention here. This gets a closed circle because my inequality is underlined. So at -2, 1, and then -3, 6. Those are the only 2 that are going to fit here. So I'm just going to do my best to make this look curvy to imply that it is parabolic in shape, and it's going on forever because I don't have a second boundary here. For my other function, I'm looking at values from -2 to +8, so I'm going to get all of those in here. And I'm going to go down one more just to make sure I can get a clear idea of what's happening. And this is going to be -x minus 6. Now, when I have a negative, minus a negative becomes positive, so keeping that in mind, I'm going to get -4, -5, -6, -7, -8, -9, -10, -11, -12, -13, and -14. Again, fitting as many of those as I can. At -2, I'm going to have an open circle. And at 8, I'm going to have a closed circle. So making sure I account for all of that. I can plot a few more points just to get an idea of what my graph should look like. But this is going to go until I reach 8, -14 with a closed circle. So now that we have reviewed all of that graphing, let's write some equations from the graph. Your first goal here is to figure out what are your 2 or 3 intervals. For this first equation on the left, I've got a horizontal line starting at -3 with an open circle, and we're going off to -infinity. So that means x is going to be less than -3. And on my second one, I'm starting with an open circle at +3 going off to +infinity. So that means x is greater than 3. Both of those are open circles, so that means that I don't underline. On the left, I've got that horizontal line, which means it's just going to be y equals the y value there, which is -4. So that one's nice and easy, but for the other one, I am going to need slope-intercept form, so I have to calculate the slope and the y-intercept. I need 2 points to do that, so I'm going to use the point 6, -6, and 3, -1 to calculate my slope. Plus positive, and I get -5/3 for my slope. Now I need my y-intercept, and I'm going to find that by plugging in my slope and one of my coordinates in for x and y to solve for b. I'm going to use 3 and -1 here. You could use the other coordinates and get the same results. And I did my math wrong. Pause. That should be -5. Apologies. So adding, I get that b is 4. So my second equation, -5/3 x plus 4 when x is greater than 3. On the second one here, I have 3 parts, starting with an open circle at -2, going off forever. Then I've got a closed circle at -2 to an open circle at +1. So I'm only going to underline the one between x and -2. Then I've got a closed circle at +1 going off forever. So I need to find the equations of these 3 lines. Again, I'm going to be using slope-intercept form. For the first one, to get my second point for -2, that will help me calculate my slope. So that slope is 1 minus -2 over -2 minus -4. All of that becoming positive. I get 3 over 2. Now I need a y-intercept. I'm going to use -2, 1 as my coordinates here. And I get that b is also 4 for this one. So that's 3 over 2x plus 4 for values of x less than -2. On to the middle one. I can see those 2 points pretty clearly. So for those points, that's going to be 8 minus 5 over 2 minus -1. And that gives me 3 over 3, which is 1. And I can actually see where it crosses the y-axis here at 7, so I don't need to calculate the y-intercept because I can see that it's 7. And then lastly, for slope on my third line, I'm going to use 2, 2 as my second point. And my slope there is going to be 2 minus 7 over 2 minus 1, which gives me a slope of -5. And then I'm going to use 2, 2 as my coordinate to find b. And I get that b is 12. Okay, moving on to a wordy problem. We are going to graph and write the piecewise function here. So Farah left her house at time 0 and drove to the store, which is 6 blocks away at a speed of 3 blocks every 4 minutes. This information is important because it tells me my slope there is 3/4. So she's starting at 0, 0, going 6 blocks away. If she's covering 3 blocks every 4 minutes, that tells me it's going to take her 8 minutes to travel those 6 blocks. So I'm going to connect those 2 points, 0, 0, 8, 6. There's my first interval. Then she stopped at the store and went inside for 2 minutes. Well, that means for the next 2 minutes, her distance is not changing. So it's going to be that horizontal line until minute 10. From there, she's going to drive in the same direction at a speed of 3 blocks every 2 minutes. Well, that tells me my slope there is 3/2. And she's going to the bank, which is another 6 blocks away from the store. So this time, covering 3 blocks every 2 minutes, to travel those 6 blocks, that's going to take her 4 minutes total. So at 14, and then going from 6 to 12, that gives me the points to connect for my third leg of our trip. Then she's in the bank for 5 minutes. So from minute 14 to minute 19, she is going to be staying at the same distance away. Then she's going to drive home at a speed of 6 blocks every minute. So if she's 12 blocks away, that tells me it's going to take her 2 minutes to get home. So she's driving home super duper fast, much faster than she was going to the bank or to the store. So there's the graph for Farah's travel. Now let's figure out what our piecewise function is. Oh, and I guess I should specify here, if she's going back home at 6 blocks a minute, her slope is going to be -6 because she is backtracking home. Okay, I've got 5 intervals here, so let's list our x values. I'm starting at 0 and then ending at 8 for the first one. And both of those are included. I've got closed circles here, so I'm going to underline both of them. For my second interval, I'm going from 8 to 10. And while I do have closed circles here, we have to make sure we only account for each x value one time. Otherwise, we no longer have a function. Your x's cannot repeat. So because I included 8 in the first interval, I'm not going to include it in the second, but I will include the 10. Then my second interval is from 10 till 14. And then again, same story here. I'm going to include the 14, but not the 10 since we included it previously. Then when she's in the bank, that's from minute 14 to minute 19. Again, I will only include the 19. And then from minute 19 to 21, when she goes home, only including the 21. Now I need to figure out these 5 equations. On the first leg, we knew her slope was 3/4. And she's starting at the origin, so her y-intercept is 0, so I just need 3/4 x. On the second leg, it's a horizontal line, so that's just going to be 6. On her third leg, we know the slope is 3/2, but I need to find the y-intercept. So I need to use one of my points. I can use, for example, 10, 6 to find my y-intercept. And I get -9. So there's my third equation. Back to another horizontal. This time y is just 12. And then on the last one, we know we have a slope of -6, but to find that y-intercept, I'm going to use the point 21, 0 to find my b value. And I get 126. Okay, and I'm running low on time, so I'm going to record the last question in a separate video.